Assalamualaikum to IR Dr. Nawar Aswan. In this video, our group will be presenting on the mechanism to harvest fresh fruit bunch from tree. So our group is team 2, consists of me, Arif Farhan, Leong Ming Rui, Mohamad Adib bin Mohamad Hisham, and Mohamad Irfan. So our group in charge for the mechanism to harvest the FFB from the tree, and we come up with several ideas. But before that, let me introduce our group organizational first. So this is our group structure for team 2, which consists me as project manager, Muhammad Arif Farhan. Also, our group structure consists of 3 layers, which is senior management team from final year, and then the mechanical design engineer team from third year. Also, the last one is the mechanical drawing team from the first year. So each layer of team consists of team leader, which was in charge by Umay Bala for the team leader in mechanical design engineer team. Also, Isman Azmi for the team leader of mechanical drawing team. Also, my assistant project manager is Leong Ming Rui. So this is our Gantt chart, consists of several division. The first one is the division of planning, which consists of the identification of problem, background design study, project planning, and so on. Also, the second one is the design stages, which consists of modeling of design made by third year and final year. Also, the design conceptual selection and finalization. And the third one is the engineering analysis made by third year and final year. The fourth one is economic analysis, mainly by fourth year, but assisted by third year. The fifth one is technical drawing made by third year. First year. Also the technical report. And last one is the presentation preparation and presentation day. Okay, so before we introduce our design concept for this project, let me briefly introduce about the FFB palm oil plantation. So generally, there are two methods to harvest the FFBs practiced by real life scenario, mainly manual harvesting and using machines. So the traditional method is the method that manually harvest involve the use of cutting tools such as sickle or chisel. So these are the common method used by harvester nowadays due to the cost of tools, also the ease of usage. And the second one is the harvesting using machine, which comprise motorized cutter, harvesting truck, or drone. However, the use of drone in motorized cutter is really rare due to the cost of the drone, also the complexity to control the drone. So we come up with several ideas that we propose to ease the harvester to harvest the FFB in the palm oil plantation. So I'll pass the presentation to the next presenter.
Hi, my name is Mohamad Adib, and now I will continue with the design concept. So there is three design concept for harvesting mechanism that has been proposed, which is first is mechanism directly controlled by harvester, such as in figure 1. Second is mechanism installed to the truck or mover, such as in figure 2. And lastly, a mechanism installed to the drone as shown in figure 3. So from this design concept, the third mechanism has been chosen and selected, which is by using drone as our harvesting mechanism. After undergoing concept screening and concept scoring based on a few design criteria. So next is the design criteria that for the choose of harvesting mechanism, which is the affordable price, accessibility that can use in any height, safety features, durability that can withstand specific load, stability, and portability. Next is the design concept of the cutting mechanism. So our mechanical design engineer team has proposed 6 different design concepts of cutting mechanism. So the design concept will also undergo the concept screening and concept scoring to choose the final design for the cutting mechanism. And the final cutting mechanism are as shown in the figure that consists of pulley, arm, brushes, motor blade, and tooth belt. So next, this is the design criteria for the cutting mechanism, which is the durability. the cost, feasibility, that is able to transport, the features, safety and maintenance. So this is the final design of our harvesting drone, which is it has a base. It consists of drone frame and landing gear. And then the other main component, which is drone propeller for the flying purpose, and robot arm to expand to reach the tree, pushing mechanism to give a grip for the drone, and the branch and cutting mechanism to cut the branch. So next is the final design. There is two modes in the final design, which is the rest mode where the drone is not in use, and the harvesting mode where the drone need to where the robotic arm will expand to cut the branch, and that's all. So next is the work breakdown structure for our harvesting drone. There is the first level, and the second level is consists of drone cutting mechanism and pushing mechanism. Then continues the level 3 and level 4 for the smaller component. So this is the standard view for the drone, the bottom view for the drone, and the attachment plate where the cutting mechanism and pusher mechanism are attached to the drone base, drone frame. So, and lastly, this is the propeller, which consists of the motor and propeller. And that's all from me. I will pass to the next presenter. Thank you.
Thank you. I am Leong Ming Rui, and I will continue on the engineering analysis. Before the design is finalized, many engineering analyses are performed on the drone to ensure the requirement is fulfilled. Generally, the third-year student who work on the major component, the robotic arm, conducted analysis including material selection, some stress analysis, bearing selection, and fastener selection as per the requirement of their lecturers. Then the final year student would work on the rest of the part. Since there are a lot of analysis, I will focus on presenting one of the analysis that we work on, which is the stress analysis on the drone body to show the general process of the analysis. So first of all, we'll determine what are the parameters, what we have and what we want. In this example, we perform the stress analysis on the attachment plate, which is a plate for mounting the robotic arm, and the hydraulic power unit HPU on the drone. Since these two objects are quite heavy, we want to know the stress and is the plate strong enough to withstand the stress. Then, since the plate only receives the bending load, we model the plate as a beam, draw the free body diagram, find the dimension, the weight, the material properties, which were selected to be stainless steel 304 beforehand, and the design factor of 2.4 as per precaution. Then the next step would be calculation and simulation. For beam analysis, we would use this formula from strength of material to calculate the shear force, the moment, and until the bond resistance stress and the deflection. Then as for simulation, we would use the same parameter from the previous slide and to find the stress and deformation either in SolidWorks or in ANSYS. Then the final step would be the discussion. So for analysis with simulation as such, the value from the calculation and the simulation are compared. For instance, the percentage of difference for the calculation and simulation for stress and safety factor are below 10%, while the value for maximum displacement is higher. So from here, we would say that the calculation generally agree with the simulation or verified, but the error for the max displacement may be higher because that it is hard to model the plate with only beam equation, or we made wrong assumptions. So if the results here shows the design fail, or as in the stress is above the yield strength, or the safety factor is not high enough, iteration will be performed. Otherwise, we'll say that the analysis is completed. So here shows the result of more simulation, in which the left two is the stress analysis of drone as well, while the right two are the stress analysis on the shaft and arm of the robotic arm by the third-year student. So that's all for me. I will pass to the next speaker. Thank you.
Now I will present about the economic analysis. Okay, first of all, I will explain about the bill of materials, BOM. So there are 30 plus of fabrication parts, then 300 plus of fasteners, and then 220 plus of purchase parts. So based on ballpark figure on the fabricated parts, fasteners and purchase parts were obtained from the work breakdown structure and listing of parts after combining the drone pusher mechanism and arm cutting mechanism. Then for the cost analysis, for first of all, manufacturing cost, they are for the raw material, they are 25 quantity and the total cost is 5,015.18 ringgit. Then for the purchase part, there are 24 quantity which the total cost is 947 ringgit. Then for the total investment, which is the total of the sum up of the manufacturing cost, so the value is 5,962.18 ringgit. Then for the current value, which the price of our drone, the value is 6,897.75 ringgit. Then for the return of investment ROI, we can get from the based on two value, which is the total investment and current value, based on the calculation below the table. Then we can get the value for ROI is 18.65%. So based on that, we can ensure that our harvesting drone can be completed and it is possible to commercial widely in agricultural field market. Okay, next for the technical drawing. Firstly, we make sure that title block format is completed. And then because of our drawings follow the hierarchy of the BOM, so we can distribute the task easily. So for the assembly and sub-assembly is made by senior management team, which is 4-year group members. And then for the parts is made by draftsman, which is first-year group members. So this is example of title block. And then for this is example of shaft 30 mm, where this drawing is made by a draftsman. So that's all from me. I pass to next presenter.
As the end of our video, we come up with several conclusions about our design, which is the drone harvesting mechanism. So the first one is the harvest with zero effect. The traditional method gets harder for trees with height beyond 5.5 mm, 5.5 meter. This is because a pole above twice the height of the user will be difficult to maneuver, leading to accident. So our drone increase the harvester safety by harvesting the palm oil from far distance. Also, the second one is the unreachable height. Drone is one of the breakthrough for smart and autonomous precision agriculture farming, which provides practical solution for precision farming. Harvesting with drone may help the harvester to harvest palm oil tree more than 10 years, which has more than 5 meter high up to 18 meters. This is the height the traditional method cannot be reached, but require a longer tool or sickle, which might be difficult to carry out along the palm oil plantation. And the third one is the future to full automation. Drone is one of the breakthrough for smart and autonomous precision agriculture farming, which provide practical solution for precision farming. Also, our creation for drone in palm oil plantation harvesting method is along with the goal towards Industrial Revolution 4.0, which the use of automated drone to harvest the palm oil inside the palm oil plantation without the use of traditional method. And the last one is the smart and compatible. The design of the drone in this project is made to be compatible as it is easier to carry from one place to another, and the components are detachable. This made the harvester easier to carry out our drone throughout the plantation. In the future planning, there are several things will be added into the drone, which is the artificial intelligence and improvement of smart control will be added for drone to be fully automated, so that the harvester doesn't need to be inside the plantation while controlling the drone from the control center. So I guess that's all for our presentation in this video. Thank you.